All right, so when we talk about indeterminate forms like the ones we've talked about, the 0 over 0 form, remember we're not actually dealing with 0 over 0. We're dealing with a really small number over a really small number, numbers that keep getting infinitesimally smaller. And so sometimes, depending on which of the numbers goes to 0 faster, that value could range from anywhere from 0 to infinity or negative infinity. Okay, so a 0 over 0, we just don't know what it is. It's not truly 0 over 0, it's just very small over very small, and they keep getting smaller. Okay, just so you know, like, so for instance, if I have x over x squared, right, and I'm letting x go to 0, that's a 0 over 0 form. But x squared goes to 0 much faster, and so even though it's 0 over 0, that will equal, this is of course as x goes to 0, that will equal infinity. All right, which is really interesting. On the other hand, if I have x squared over x, okay, that one is going to go to 0. Okay, so, but they're both of the 0 over 0 form. So indeterminate forms are these situations where we end up with really small numbers over really small numbers. And of course, like we said, we also have the infinity over infinity, which is really big over really big. Um, and so what we don't really know whichever one gets bigger, the top or the bottom, whichever one gets bigger faster determines whether that goes to anything from ranging from 0 to infinity. All right, so that's what we mean by indeterminate forms. Now there are lots of other indeterminate forms. For instance, uh, this is an indeterminate form. Now I should say these are the two most common ones, and those are the ones where L'Hopital's rule applies immediately. Okay, but suppose I have an expression where I've got 0 times infinity. So a really small number times a really large number. So here's an example. So if I'm taking the limit as x goes to 0 from the right side of x ln of x. Okay, so just look at the pieces. X is going to 0, so that means that is going to 0, getting smaller and smaller. This, on the other hand, is going to negative infinity. Right? So if you remember what the graph of ln looks like, it shoots to negative infinity. Let me just quickly sketch it in here, right? So here's the graph of ln of x, right? And so of course, as we are getting closer to 0, this graph is shooting down to negative infinity. So this is one that fits into the 0 times infinity or 0 times negative infinity, or a very small number times a very large number. And so which one is going to win out and force us to actually reach a value? Does x get smaller so fast that it just dominates the ln of x and turns the whole thing into 0? Or does ln of x get bigger so fast that it just dominates and overrides the smallness of x? So that's what we mean. It's impossible to tell what that is equal to. So L'Hopital's rule will work with this whenever you deal with indeterminate forms of this form, 0 times infinity or negative infinity. You have to change the expression into one of these. We will always be changing into either 0 equals 0 or infinity, 0 over 0 or infinity over infinity. All right. So in this case, we can do it like this. We can say, all right, let's just keep, this is the same as ln of x over 1 over x, right? If I just take that x and invert it and put it on the bottom, that's the same thing. I didn't do any algebra or I'm sorry, any calculus there. I just took the x and put it as a 1 over x. And if you simplify this, you will see that it becomes this. So they're equal. Those two things are the same. Okay, but look at this one that we just wrote. This one is now negative infinity over infinity, right? As x goes to 0, 1 over x goes to infinity. So now this is one of our standard indeterminate forms, infinity over infinity. And so we can now just apply the L'Hopital's rule and take the derivative of the top, Derivative of ln of x is 1 over x. Derivative of 1 over x is negative 1 over x squared. Do a little bit of algebra here, right? Invert that bottom one. So it becomes, this all becomes negative x squared over x, or negative x, right? When you simplify. So as x goes to 0, negative x goes to 0. And there's our answer. So if you end up with a 0 times infinity indeterminate form, or any of these forms we're going to talk about, you need to change it to either 0 equals 0 or infinity over infinity, and then apply L'Hopital's rule. All right, let's try another one. So let's look at something like this. So the limit as x goes to 0 of 1 over x squared minus 1 over tangent of x. Okay, so what's happening here? X is going to 0. So this is going to infinity, right? Because x is getting smaller and smaller. 1 over a tiny, tiny number. So that's infinity. Minus 1 over, what does tangent do? Tangent is going to 0 as well. So this is going to infinity. So what we end up with is a very large, we basically end up with infinity minus infinity. Okay? So that's the form we end up with. And that's an indeterminate form. In other words, a really large number minus another really large number. Which is going to win out? Well, it depends on whether this one gets bigger faster than this one or vice versa. But that's an indeterminate form. L'Hopital's rule can be applied if we can transform this into 0 over 0 or infinity over infinity. So we're just going to do a little algebra. Probably the best thing to do here is just to combine these things. Right, we got two fractions, so a common denominator would be x squared tangent of x. And then, of course, we end up with a tangent of x minus x squared. Okay, so if we look at that one now, as 0 goes, or as x goes to 0, tangent of x goes to 0, minus 0. So the top is going to 0. The bottom is going to 0, 0, so the bottom is going to 0. So now, all of a sudden, this is a 0 over 0 form. And now we can apply L'Hopital's, which says take the derivative of the top and the derivative of the bottom. So, of course, the derivative of tangent is secant squared minus 2x over, now we're going to have to use the product rule to take the derivative of the bottom. So 2x tangent of x plus x squared secant squared of x. Okay, so now let's imagine x is going to 0. What are these things going to? Well, secant is going to 1. So I'll write these in as we go. Secant, this is going to 1. This is going to 0. So all told, the top is going to 1. How about the bottom? Well, this is going to 0. This is going to 0. So that's going to 0. This is going to 0. This is going to 1. So in other words, the bottom is going to 0. So we've got kind of a 1 over 0. But the big thing is the top is getting closer to 1. The bottom is getting smaller and smaller. And so we know that will equal infinity. 1 over something really, really tiny is infinity. Okay? All right, so there are a couple other indeterminate forms that you're going to look at, and I'll let you look at the examples in the book on those. But for instance, infinity raised to 0, right? So a really big number raised to a really small number. Well, what is that going to become? Again, this is going to be something where you want to change it so that it's infinity over infinity or 0 over 0, and then apply L'Hopital's. 0 raised to the 0. Okay, so something really tiny raised to something really tiny. Okay, and so there's some examples of those kinds of things in our book. All right, so that gives you an idea of how to evaluate some of these limits that end up in strange places. All right, so good luck with that, and Let me know if you have questions.